graphed the first problem, so if you need to stop the video to catch up, I graphed my points, connected my lines, and made an estimate, made a guess that this is a square. I made a prediction or assumption. Now, this is coordinate proofs. Okay? Coordinate proofs aren't the scary proofs that we did earlier in the semester. Rather, this is just, I'm going to make a claim. This is a square, and I'm going to use math to back up that I know this claim to be correct. So, to do that, we have to make an assumption here. So, we've assumed that this is a square. So, if this is a square, what do we know to be true about squares? So, we could list some things, right? We know they have 90-degree angles. We know they have equal sides. We know their diagonals are perpendicular. We could list all these qualities, right? Well, if this is really a square, these are some of the things that we want to prove. Like opposite sides, parallel, sorry, some things are coming to my mind here. We want to prove these things to be true. So this worksheet kind of steps you through those concepts. So we want to find the length of each side and both diagonals to the nearest 10th. So remember, to do that, you can either use the distance formula, or you can create right triangles and use the Pythagorean theorem. I'm kind of a fan of the Pythagorean theorem here, so I'm going to create these right triangles. To each his own, though. You can use the distance formula. So this is 1 by 8. So 8 squared is 64, plus 1 is 65. So AD is the square root of 65. I'm not necessarily worried about the decimal approximate right now. I'm going to make this right triangle here. This is 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And for me, that is the same thing. So DC, square root of 65. My line got a little crooked here, but this is 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is all the square root of 65. Now, they want us to find the length of the diagonals. To do that, I'm going to use the distance formula since I can't, so I don't have to use the Pythagorean theorem for these diagonal lines. I'm just going to use the distance formula. So to do that, let's see, A to C. So A to C, I'm going to say that is, shoot, I'm just going to put it in my calculator because I know that's what all y'all boogers are doing. So the second square root, we have 4 plus 5 squared plus -1 minus 6 squared. And I'm going to get the square root of 130. So that was AC. Then the same thing for BD. So second square root, I'm going to say -4 minus 3 squared plus -2 minus 7 squared. I get the square root of 130. So the diagonals are equal to, which is characteristic of a square. So what conclusions can you make? Just based on that information, I can say all sides are equal. And it's not all diagonals, there's only 2. And diagonals are equal. And if you wanted to say congruent instead of equals, those are the same thing, y'all. Okay. What about slopes? So what we've proven here is we've proven equal sides. So I need some other qualities here. So we can find the slopes of each side and both the diagonals. Well, remember, if we're talking 90 degrees, that's perpendicular. And when we wrote the equation of perpendicular lines, those were opposite reciprocal slopes. So that's what we're hoping to find here if we truly have four 90-degree angles. So looking at the slope of AB, I rise 1 and go over 8. So that's 1/8. DC, I'm going to, depending on what direction you go, but it's rise over run. So I'm going to rise 1 and run 8. So that's 1/8. Okay. So there's a couple of things here. We also said, okay, yes. BC, we're going to rise 8, but go to the left 1. When I go to the left, that's negative. So that's -8. Same thing here for AD. When I rise, I'm going to, well, or I could fall 8 and go to the right 1. But if I'm falling 8, that's -8. So there's a couple things that are happening here. So the first being, we found opposite sides are parallel. Remember, parallel means the same slope. So if that's true, then let's see. These two, this is opposites, are parallel. BC and AD, these are opposites, are parallel. So we've proved that. Okay, they have the same slope. We're looking to prove that we have a 90-degree angle. We need opposite reciprocal slopes. I'll use a different color here. So AB needs to be parallel to AD. So AB and AD, those are perpendicular. Okay. BC and CD, those are opposite reciprocals. 1/8. Flip it over, get an 8, opposite, negative. So these are also perpendicular. And I can go through each one of those sides. So we've proved 90 degrees are perpendicular. The last one is to prove that the diagonals are in fact perpendicular. So to do that, you could connect your lines and count your slopes. I'm going to use the slope formula really quick. So when I use this slope formula, I'm going to say, let's see, for AC, we have y, so y2 minus y1 over x2 minus x1. So we have -7/9. And for BD, so y2 minus y1 over BD, -4 minus 3. So this is -9 over -7, so 9/7. Those are opposites, the signs changed, and they're reciprocals, those fractions flipped over. So we've proved the diagonals are perpendicular. So what conclusions from this math can we make? One conclusion is opposite sides are parallel. The second thing we conclude is opposite, or no, opposite sides are perpendicular, but we have 90-degree angles. They're perpendicular, right? And the third thing is the diagonals are perpendicular. So with all this information together, we made a claim that it was a square. We provided all this math to support all of these things, and it is, in fact, a square. Okay. All right. I'm going to continue with another example here. Okay. I'm going to pause my video, graph it, make a claim, and I'll probably pause and continue to work here so the video stays within my time limit. So let's begin working on this next example together. So when I graphed it, I found that this is a trapezoid, and I had to think of some things I know. I know that in a trapezoid, bases are parallel. If it's an isosceles trapezoid, my legs will be congruent. My diagonal should be congruent. And that's all I could think of off the top of my head. You might have to go back through to your previous unit, Unit 1, to find these characteristics, that flow chart, to see what we're trying to prove and set up here. Now, I'm going to work on finding these side lengths. I encourage you to pause the video and find the side lengths that they're asking for and see what conclusions you can make. All right, let's look at our lengths and see what we can conclude. So looking at my findings, okay, when you work with this trapezoid, you're not going to make a full square. You have to make that 90-degree angle per each of those side lengths. So when I do that, I find that I have two equal side lengths, BC and AD, and those are actually the legs. So it looks like we've taken care of two legs being congruent here. Okay. We've also shown that our diagonals are congruent. So we've taken care of that piece. So the conclusions we can make are that we have legs congruent and diagonals are congruent. So let's take a moment and find the slopes of these. So if you've labeled your triangle based on the distance, you should be able to find the slope a little quicker. So for example, AB is 12 over 11, rise over run. DC, I'm going to rise 5 and go over 5. So that's a slope of 1. 5 over 5 is 1, right? BC, I'm going to rise 6 and go over 1. And for AD, I'm going to, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh shoot, this should be a 12. So this balances to be 1, because we need parallel sides, y'all. And so that's going to change AB here. See, this is why I should talk things out loud. So 144 plus 144 is the square root of 288. There we go. We fixed it. Square root of 288. Okay. AD, we're going to go up 1 and over 6. Okay. The slope of AC, we're going to have to calculate real quick. So AC, so 3 plus 3 divided by 6 plus 5, I get 6 over 11. And the next one, BD, I have y2 minus y1 over x2 minus x1, 9. So negative 11 over negative 6, so 11/6. All right, so what does this tell us? Well, it tells us here that we do have our bases are parallel. It's the same slope after I made my edit there. Sorry, y'all. A slope of 1 and a slope of 1. So we have parallel lines. The other pieces aren't perpendicular, though, and my slopes and my diagonals aren't perpendicular. They are reciprocals, but remember, to be perpendicular, you have to have opposite reciprocals. So I have two sides parallel. So what have we proven? We've proven it is a trapezoid, but with those equal legs, we've proven it's an isosceles trapezoid. Continue to practice and text me on Remind on what geometric proof, what coordinate proof I'd like to see. Happy proving!